Hello everyone and welcome back. My name is Mr. Kovold, and in this video I'm going to be going over how to use atomic mass as a calculation in your calculation problems. So in a lot of ways you can use the atomic mass as a molar mass, which can then help you convert between moles and grams. So let's go over a couple of problems. So the first problem is regarding boron. So boron is an element on the periodic table, of course. So the first question they're asking us is write the molar mass of boron as a conversion factor that can be used to convert between grams of boron and moles of boron. Well, the thing to keep in mind here is, as I just said, the atomic mass on the periodic table can be used as the molar mass of the element. It's the exact same number. So all you need to do is look up the number, the atomic mass, which is usually that decimal number below the symbol on the periodic table, and that's going to be the molar mass. It's the same number, except remember, molar mass is the number of grams per 1 mole of that substance. So in this case, boron is going to be 10.811, right? So if I write that down, so 10.811 is the atomic mass. So this would be AMUs for one single atom of boron. So one single atom of boron is going to be 10.811 AMUs, atomic mass units. But if we're talking about 1 mole of boron atoms, then all we have to do is just change that unit here to grams per 1 mole. So then this becomes 10.811 grams over 1 mole. So that would be the molar mass of boron. So if I put B here, so 10.811 grams of boron is equal to 1 mole of boron. Or we could switch it, right? So this is one conversion factor we could use. But remember, the conversion factor can be flipped depending on which direction you're going. If you're converting from grams to moles, then you're going to want to use a different conversion factor than if you're going from moles to grams. So you can flip it. So instead of 10.811 being on the top, you can put it on the bottom. And then 1 mole will be on top. So either of these are perfectly fine conversion factors that you could use. Which one you use will depend on which direction you're going. Are you going from grams to moles or moles to grams? Okay, with that segue, let's go ahead and get into part B. So here they're asking us to calculate the mass in kilograms of 219.9 moles of boron. So we're going to start with moles, and we got to get to kilograms. That means we got to get to grams first. We're going to need to use the molar mass. So let's start with the 219.9 moles of boron. Put that over 1. To get to kilograms, we need grams first. To go from moles to grams, we got to use the molar mass. So since we have moles on top here, we're going to have to use the conversion factor that has moles on the bottom. So this one has moles on the bottom. So we're going to have 1 mole of boron on the bottom. And we're going to put the 10.811 grams of boron on top. So moles cancels out. You might have noticed that I dropped the E in mole. This is an abbreviated way in which we write mole, so MOL instead of MOLE. Next, now that we have grams, now I can convert grams to kilograms because I know 1 kilogram is equal to 1,000 grams. That's what kilo means. Kilo means 1,000. So I can use that to convert. So I can put 1,000 grams on the bottom because I have grams on top. I want grams to cancel. So I'm going to put 1 kilogram of boron on the top. So grams of boron cancel out. Now I have kilograms. So now all I need to do is multiply and divide. So I'm going to multiply by the top. Excuse me. I'm going to multiply by everything on the top. Excuse me, I need a drink of water. Pardon me. So I'm going to multiply by everything on the top, and then I'm going to divide by everything on the bottom. And when I do that, I get 2.377. 2.377 kilograms of boron. And so that's how you get from moles to kilograms. And again, the number of sig figs is the same as the least number. So remember, whenever you multiply and divide, the number of sig figs in your answer should be the same as the least number of sig figs in your measurements. So I have 5 sig figs here in my molar mass. This is exact, so I don't need to deal with this one. I can ignore that. And then I have 4 here. Since 4 is the lesser of the two, I should have 4 sig figs here. So next is C. Now we're going to calculate how many moles of boron are in this many pounds of boron. So let's do that one. Okay, so now I'm given pounds of boron and I need to get to moles. So we'll start with pounds. So I have 0.1532 pounds of boron over 1. And I'm going to need to get to moles. Now, in order to get to moles and use molar mass, I need grams, right? So I can't convert to moles using the molar mass unless I have grams because it's a conversion between grams and moles. So I need grams. So that's my first thing that I need to get to. So how am I going to get from pounds to grams? There's a number of ways you could do that. You could convert this to kilograms using the 1 kilogram is equal to 2.2 such and such pounds. And then convert kilograms to grams and then go from there. Or you could use 1 pound is equal to 453.6 grams. So I'm going to go ahead and use that one. So 1 pound is going to go on the bottom because I have pounds here. I'm going to put 1 pound on the bottom, 1 pound of boron, and then 453.6 grams of boron on the top. So now pounds of boron cancels out. Now I have grams, so now I can use the molar mass to convert to moles. So I'm now going to set that up. And since I have grams on top, I'm going to need grams on the bottom. So this time I'm going to put the 10.811 grams of boron on the bottom. So 10.811 grams of boron on the bottom and 1 mole of boron on top. So now grams of boron cancels out. Now I have moles of boron on the top. That's what I want. So now I'm done with the conversions. All I need to do is multiply by everything on the top, divide by everything on the bottom. And when I do that, I get 6.428. 6.428 moles of boron. And once again, I have 4 sig figs here. Remember the rule, the number of sig figs in your answer should be the same as the least number of sig figs in your measurements. Here I have 4 in my conversion factor. Here I have 5 in my conversion factor. Here I have 4, so the least number is 4. So I have 4 there. So that's it for problem number 1. Let's go ahead and move to problem number 2. Okay, so problem number 2. Now we're dealing with gold here. So gold is often sold in units of troy ounces. I don't know if you knew that, but that's a unit of gold, troy ounces. And there are 31.0 grams per troy ounce, meaning 1 troy ounce is equal to 31.10 grams. So let's use that information to help us answer some questions. So first question, A, what is the atomic mass of gold? Well, that's easy because it's on your periodic table. So if you look on your periodic table, you find gold. So here, periodic table, you should have this with you. If you look close, find gold. Gold is number 79. So 79 right there. So gold, there's the molar mass. So it's the one on the bottom. So if you write down the molar mass, then it's going to be 196.97. 196.97, and that's going to be the unit AMU. So the average mass of a gold atom is 196.97 AMUs, or atomic mass units. So that's the answer to question A. Question B, what is the mass in grams of 6.022 times 10 to the 23rd gold atoms? Now, before you freak out, this number, you should recognize this number as very important. So 6.022 times 10 to the 23rd is the number of 1 mole. So Avogadro's number. So 1 mole of anything that you want, is going to be equal to 6.022 times 10 to the 23rd. So if you have 1 mole of students, 6.022 times 10 to the 23rd. If you have 1 mole of baseballs, that's 6.022 times 10 to the 23rd baseballs, right? So this is a very important number to remember. This means that if I have 6.022 times 10 to the 23rd gold atoms, then I have a 1 mole of gold atoms. Well, the mass in grams of 1 mole of gold atoms is the molar mass, which is the same number as the atomic mass, just in grams. So the grams of this number of gold atoms, 1 mole, is equal to this number here. So that is going to be 196.97 grams. So 196.97 grams. That is the mass of 1 mole of gold atoms. 6.022 times 10 to the 23rd. Okay, C, write the molar mass as a conversion factor. Okay, well, this is the number of grams for 1 mole. If I was to write that as a conversion factor, then I'm writing it as a ratio of grams over moles, or moles over grams. So this is one way you can do it. 196.97 grams over 1 mole. Or it would be, let me fix this a little bit, get that out of the way. Or it could be 1 mole over 196.97 grams. Either of those are conversion factors that you could use to convert between moles and grams of gold. Okay, next question. Now we're going to start to get into calculations. So first question here is, what is the mass in grams of 0.20443 moles of gold? So they want me to convert from moles of gold to grams. I'm going to have to use the molar mass to do that. So I'm going to start with 0.20443 moles of gold, AU, over 1. Now I'm going to use the molar mass to convert to grams. Since I have moles on the top here, I want moles on the bottom. So I'm going to use this conversion factor here. So I'm going to put 1 mole on the bottom, and the 196.97 grams of gold goes on top. So moles of gold cancels out. And I've got grams, so now all I need to do is multiply by the top, divide by the bottom, and I get my answer, and that is 40.267. 40.267. Where's my... So I get 40.267 grams of gold. And as you can see, I have 5 sig figs here. Remember, the rule is for sig figs, when you're multiplying and dividing, that your answer should have the same number of sig figs as the least number of sig figs in your measurements. This has 5 sig figs in here. This has 5, so the least number is 5. So I should have 5 sig figs. Okay, let's go to the next one. What is the mass in milligrams of 7.046 times 10 to the negative 3 moles of gold? So now they want me to go from moles to milligrams. So I'm going to have to convert to grams first and then to milligrams. So I'm going to have to start with the molar mass again. So now I have 7.046 times 10 to the negative 3 moles of gold. Put that over 1. Since I start with moles, I'm going to use the same conversion factor. I'm going to put moles on the bottom to cancel out moles on top. So 1 mole of gold, and then the 196.97 grams of gold goes on the top. So moles of gold cancels out. Now I have grams. So now I can get to milligrams, but I need a conversion factor between milligrams and grams. You need to know your prefix multipliers. You need to know your metric unit conversions. Milligram, what does milli mean? Milli means 1/1000th or 10 to the negative 3. So 1 milligram is equal to 10 to the negative 3 grams. So I'm going to use that as a conversion factor. So since I have grams on top, I'm going to put grams on the bottom. So 10 to the negative 3 grams of gold. And then on top, I'm going to put 1 milligram of gold. So grams of gold cancels out. I have milligrams of gold on top. I am done. So now all I need to do is multiply by everything on the top, divide by everything on the bottom, and I get my answer. And when I do that, I get 1388 milligrams of gold. And so again, you can see that my significant figures are 4. And so again, my answer should have the same number of sig figs as the least number of sig figs when I'm multiplying and dividing. Here I have 4 sig figs. Here I have 5. This is exact, so we can ignore that. So the least number is 4. So I should have 4 sig figs rounded to the next unit, 1388 milligrams of gold. Okay, last but not least, how many moles of gold are in 1.00 troy ounces of pure gold? Okay, so they're giving us 1 troy ounce of pure gold. So we'll start with that. So 1.00, and I'll put troy, I'll put TO for troy ounces over 1, and this is troy ounces of gold. We know that 1 troy ounce is equal to 31.010 grams. So we're going to use that as a conversion factor. So since I have troy ounces on the top, I'm going to put 1 troy ounce on the bottom and 31.10 grams of gold on top. I forgot my gold here. So troy ounces of gold cancels out. Now I have grams of gold on the bottom. We want moles, and I have grams. So to convert grams to moles, I use the molar mass. So we're going to use the molar mass as a conversion factor. So I have grams on top. I want to put grams on the bottom of my conversion factor. So I'm going to use this one here. So 196.97, that's right, of gold on the bottom and 1 mole of gold on top. So grams of gold cancels out. Now I have moles, so I'm done. All I need to do is multiply by everything on the top, divide by everything on the bottom. And when I do that, I get 0.158. 0.158 moles of gold. And once again, you can see that I have 3 sig figs here. The reason being is because I have 3 sig figs here. Again, the number of sig figs in your answer when you multiply and divide has to equal the least number of sig figs in the measurements you are multiplying and dividing. Here I have 5 in my molar mass. Here I have 4, and here I have 3. So the least number is 3. So I should have 3 here rounded to the next decimal, or that next number. And so that, ladies and gentlemen, is how you do atomic mass calculations using molar mass. I hope this is helpful. If it was helpful, if you learned from this video, then please, by all means, like the video, share the video, hit that like button. Also, subscribe to my channel. Hit that notification bell when you do. Make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. If you have a topic you want me to cover, if you have a question or a problem you need help with, put that down below. I would love to help you with that. Thanks for joining me, and have a great day.